Welcome to this quantitative problem set on geometric optics, featuring problems with step-by-step solutions. This set includes two outcomes on application of Snell's law. In problem 8, we apply Snell's law to find the angle of refraction when light moves from air, with an index of 1.00, into water, with an index of 1.33, at an angle of incidence of 45 degrees. Our goal is to determine the angle of refraction, theta 2. We use Snell's law, n1 sine theta 1 equals n2 sine theta 2, rearranging it to solve for theta 2. Substituting the known values and calculating the result, we find that the angle of refraction is approximately 32.1 degrees. This means the light bends toward the normal. In problem 9, we again use Snell's law to find an unknown index of refraction. Light travels from an unknown liquid into air, with an index of 1.00. Given the angle of incidence is 35.0 degrees and the angle of refraction is 50.0 degrees, we need to find the index of refraction n1 of the liquid. We rearrange Snell's law to solve for n1. n1 equals n2 sine of theta 2 divided by sine of theta 1. Substituting the known values, the calculation yields an index of refraction of approximately 1.34. This value is close to that of water, indicating the unknown liquid may be water or a water-based solution.